Today I will introduce a theorem called Glasser's master theorem. And we will first present the content of the theorem, then prove it, and finally provide an example of its application. So the theorem states the following. If we assume that the integrals written below are convergent, then we have integral minus infinity to infinity f of x minus a over x dx is equal to integral from minus infinity to infinity fx dx, where a is a positive number. So now we prove it. Let's prove it. The method I will use is integration of substitution. So let's consider u is equal to x minus a over x. Then we can times x on both sides. We can get u times x is equal to x squared minus a. And we will get x squared minus ux minus a is equal to 0. So we can solve the x is equal to 1/2 times u plus minus square root u squared plus 4 times a. And let's calculate dx, and is equal to 1/2 1 plus minus u over square root u squared plus 4 times a and du. Let's just use the chain rule. Okay. So let's consider when we will choose the positive or negative. And we notice that this term is always the absolute value is always bigger than this. So when x is positive, it means this is choose plus, and if x is negative, then we choose minus. So we consider this integral to split two parts, and it looks like for the first part is from minus infinity to 0 f x minus a over x dx, and the second part is from 0 to infinity f x minus a over x dx. And now we can use the substitution. So remember u is equal to x minus a over x, so we can write fu, and dx is equal to this thing. And because x is from minus infinity to 0, so we choose the minus 1 minus u over square root u squared plus 4 times a du. And the second part is fu, then we choose the positive. That means 1 plus u over square root u squared plus 4 times a du. And now we need to consider the boundary. So let's look at this identity. When x is equal to minus infinity, x equal to minus infinity, and this term is approach to 0. So u is approach to minus infinity. So this is minus infinity. And when x is approach to 0 from the left hand side, then this is 0 and this is approach to positive infinity. So u is approach to positive infinity. And this is x approach to 0 from the left hand side. So this is 0 and this is approach to minus infinity because the a is positive. So this is minus infinity. And when x is equal to infinity, x equal to infinity, and this approach to 0, so u approach to infinity. So u approach to infinity. Then we notice that these two things is cancelled out. So these two things cancel out, and then we can get integral minus infinity to infinity f 1 over half fu du plus integral minus infinity to infinity 1 half fu du, and that is equal to integral from minus infinity to infinity fu du. So if we let x is equal to u, because this u is a dominant variable, so it's okay to write this equal to fx dx. And we prove the solution. We prove the theorem. Okay. So let's look at an example. Integral from 0 to infinity 1 over 1 plus x fourth power dx. And first we use the integral of substitution, that u is equal to x is equal to 1 over u. So dx is equal to minus 1 over u squared. And this integral is equal to 1 over 1 plus 1 over u fourth power times minus u squared du. And when x is approached to 0, u is approached to infinity. And when x is approach to infinity, u is approach to 0. So e is equal to, we switch the bounded, and we can, e is equal to 1 over 1 plus 1 over u fourth power du, and e is equal to, times u square, and e is equal to u square plus 1 over u square du, and because it is an even function, so the integral is equal to 1/2 minus infinity to infinity, 1 over u square plus 1 over u square du, and this is equal to 1/2 minus infinity to infinity u plus 1 over u square, and this is minus, and plus 2 du. So we can use Glasser's master theorem, and we can get 1/2 minus infinity to infinity u square, 1 over u square plus 2 du, and it is equal to 1 over 1 square root 2, and inverse tangent of u over square root 2, and limit u is approach to infinity and minus infinity. So we can get the answer is pi over 2 square root 2. So this is the answer.